Good morning. So now I am going with second lecture, which is on bending stress. Now, in this student actually are always confused with this shear stress and bending stress diagram. And to clear it, you have to go with these three lectures. This is basic lecture, which is for bending stress, gate lecture number 6. Then you have two exercises which are on bending stress. Here you are going to be with simple problems. Now, I am going to consider three separate problems which are from examination. And before this, I am actually interested should be in position to go for bending stress and shear stress. So now any section you may have rectangular section, you may have circular section, you may have T section, you may have I section. So your bending stress is not going to change, or your bending stress diagram will not change its shape. For all these, my bending stress diagram is same, and therefore should not confuse with this bending stress and shear stress. Bending stress diagram is always linear. So this will be sigma top and this will be sigma bottom. So this diagram is same for all types of section. This value is 0 at neutral axis. Now we will go with three problems in this that is taken from examination. So we have this problem that was asked in May 2017. A circular pipe of external diameter 70 mm and thickness 8 mm is used as simply supported beam over an effective span of 2.5 meters. Find the maximum concentrated load that can be applied at the center of the span if the permissible stress in the tube is 150. Now, important this dimension. Student mainly going to mistake in this. So we have 70 minus 8 from one side, minus 8 from other side. And then we have this will be 54 millimeters. So capital D we have 70 millimeter and a small d we have 54 millimeters. So we have this will be internal and external diameter. Now we have given P. Now this is RA or VA, I can say better. This will be VB. As it is simply supported beam, so maximum bending moment will be at center. At center. And we have that value WL by 4. W we have P. L we have 2.5 upon 4. So this will be my bending moment. Now we will go and solve this. So we have first step 1, given data. So now you can see capital D is given, which is 80 millimeters. Sorry, we have this as 70 millimeters. Small d we have 54 millimeters. Span we have given equal to 2.5 meter. Sigma max is given 150 Newton per mm square. So these data are given. And now we will go step 2, geometric properties. Geometric properties. Now as the section is symmetrical with center, so we need not require to find value of y bar. So y bar will be at center. And now we will go directly with value of I. So we have I is equal to pi by 64 d4 minus d4. And then that will be equal to pi by 64, 74 minus 54, 4. And we have this value of I, that is 761.2 into 10 raised to 3 millimeter to the power 4. Then we have step 3, bending moment. Bending moment, already I explained this. For beam simply supported with concentrated load at center, we have M is equal to WL by 4, and that is equal to W we have P L 2.5 upon 4. So we have this will be 2.5 P upon 4. And then last step, we have step 4, bending stress. Bending stress. And we have simple formula. Sigma is equal to M by I into Y. Sigma is given 150, M we have 2.5 P upon 4 into 10 raised to 6 into Y we have 35 D by 2 upon I we have 761.2 into 10 raised to 3. And if we will solve this, then we will get value of P, that is equal to 5.22 kilonewtons. As this is in kilonewton meters, P in kilonewton, and therefore we have, if we will solve this, we will get value of P, that is equal to 5.22 kilonewton. Now we will go to the second. Now we have tension flange, that is given cast iron eye section 240 by 50 mm and compression flange 100 by 20. This is compression flange, this is tension flange, and given that 4 meter span with UDL. Find the load per meter, means we have to find out UDL if maximum permissible stress is sigma max. Now try to understand this problem. This is again most important now. So now we will be with step 1. So we have step 1, again given data. Given data. Now I will write over here only. So we have given, dimensions are given. Span is 4 meters. So I will not write dimensions. Span 4 meters. That is L. And then sigma max, we have 24 Newton per mm square. Now step 2, we have geometric properties. Geometric properties. We have given this section. I will draw over here so that it becomes easy for you to understand the things. Otherwise, we have to go always last slide and then we have to solve this. So we have given this I section 240, 50. So we have 240, we have this as 50. Then 330, so we have this as 300. Then we have this as 30. 120, so we have this will be 120. And then we will start with, so I will mark line over here. So we have Y bar is equal to AY bar upon summation A. So we have 100 into 20 into 10. So I will just take on left side. So it will be in one line only. So now I am in college, so we will come to know the noise. So we have equal to Y bar equal to 100 into 20. Now we know from center we have this distance as 10 into 10 plus 300 into 30 into, now from center, so we have this will be 150 and this will be 70. So we have total into 170 plus 240 into 50. And then from here, so we have this will be 25, then 320. So total we have 20 plus 300, 320 plus 25, 340. And then divided by 100 into 20 plus 300 into 30 plus 240 into 50. And then we will have value of y bar that is equal to 247.39 millimeter. This is from top. And y bar from bottom, we have this value. Total we have 370 minus 247.39, 122.61 millimeters. Then we have to go for I. BD cube by 12 plus A into H square. And then we have this will be 100 into 20 cube by 12 plus 100 into 20 into 247.39 minus 10 whole square plus 30 into 300 cube by 12 plus 30 into 300 into 247.39 minus 170 square plus 240 into 50 cube by 12 plus 240 into 50 into, we have 345 minus 247.39 whole square. And we have this value of I that is 351.01 10 raised to 6 millimeter to the power 4. Then we have step 3 bending moment. Bending moment, and then we have for beam with UDL throughout the span, and span we have 4 meters, and we have this value that is W. So we have this as W, and therefore we have M is equal to WL square by 8, WU into 4 square by 8, which is equal to 2W. And then we have step 4, bending stress. Bending stress. And then we have this value, sigma is equal to M by I into, always keep in mind this will be Y max. And then we have this value 24 is equal to M, we have 2W into 10 raised to 6. If we will say this will be sigma max, then this should be Y max. Upon I, we have 351.01 into 10 raised to 6. And Y max, we have Y top, which is 247.39. And from this, we will get value of W, that is 17.03 kilonewton meter per meter. So we have actually, if we will see, we have this will be 24, and this distance I have 247.39. And this distance I have 122.61. And therefore, this value comes 11.89. If I will consider this value as 24, then this will be greater than 24, which is not allowed. And then third, last problem I will consider, maximum bending moment is given of a simply supported beam is 25 kilonewton. Find the maximum bending stress, compression and tensions. And so we have to draw the diagram. So we have again step 1, given data. So here we have given bending moment. And then all data that is given in figure. So this is given 25 into 10 raised to 6 Newton millimeter. Then step 2, we have geometry. Same step we have to go for. So we have geometry. Now from the diagram, we have been given actually. So that is little bit confusing. So we have this will be 50, this is 20. So we have 20 by 20. This is 20, this is 20. So we have this will be 20, 20, and you can see we have above 60. So this will be 10, and then this will be 50. Then we have this will be 20. And bottom again, we have this as 20. And this will be 60. All dimension in millimeters. So now we will go y bar is equal to again summation a y bar upon summation a. And then we will get it equal to 60 into 100 into 50 minus 20 into 20 into 70 divided by 60 into 100 minus 20 into 20. We will get value of y bar 48.57 millimeters. This is from top. And we will get y from bottom, and that we will get it as 100 minus 48.57, it will be 51.43 millimeters. Then we have I same way, BD cube by 12 plus A into H square. So now first we have whole rectangular 60 into 100 cube by 12 plus we have 60 into 100 into H square. So we have this value 50. So we have 50 minus y bar 48.57 whole square. Plus we have to subtract due to that rectangle, which is we have to deduct from this part, we have to deduct. So we have BD cube by 12, then minus 20 into 20 into H, we have this as 70. So 70 minus 48.57 whole square. And from this, we will get value of I as 4.82. 4.82 into 10 raised to 6 millimeter to the power 4. And therefore, we will get that M is given. So step 3, bending stress. Bending stress. So now you can see this, we have simply supported beam. So we have top compression, bottom tension. So sigma C M by I into Y C. So M we have 25 into 10 raised to 6 upon I is 4.82 into 10 raised to 6 into 48.57. And we will have this value 251.92 Newton per mm. And then we have sigma tension, which will be M by I into Y tension. 20 pi into 10 raised to 6 upon 4.82 into 10 raised to 6 into 51.43 is 266.75 Newton per mm square. You can find sigma T in this fashion also, which is sigma C upon 48.57 multiplied by 51.43. Then also you will get same answer, sigma tension 266.75 Newton per mm square. And now if we will plot this diagram, then we will have this diagram. Again, I already mentioned it. Our diagram will remain two triangles. So we will have like this. Now this distance we have 48.57. And then we will have 0 over here. Get in this fashion. 0 at neutral axis. So this will be 251.92. And then this actually should be at this line 266.75. So this will be compression, this will be tension. So likewise, you have to solve the problems related with bending stress diagrams. Already shown you the different videos available on this. So thank you. Now we will stop here.